One of the challenges of teaching design is coming up with realistic, real-world motivation for students to be involved in those projects. Get them to do things that they think are going to actually have an impact outside of the classroom. Shell Ocean Discovery XPRIZE is a contest that we discovered along the way. It has a $4 million first prize, which is kind of motivating for students. It involves a really big challenge. They want to map a large chunk of ocean, 500 square kilometers of ocean, in one day, which is extremely difficult. A lot of people think it's impossible, and it may be.
We know so little about our own oceans, right? Like only 5% of the ocean floor has been mapped. We know more about the surface of the moon, which is kind of sad.
We've been teaching 4 different classes around this project for the last year and a half.
It was so interesting to get a different view of how we can use our skills to actually solve a real-life problem, not just a textbook exercise, but something that is actively being understood and in the field.
Surrounding the XPRIZE competition, the idea was to have a graduate and an undergraduate class where the students would be broken apart into different teams, and each team would work on one specific component that would eventually form our submission to the competition.
This is something that's never been done. Several parts of our project just don't exist. We have a lot of different opportunities for students to work on robotics, computer engineering, hardware design, mechanical engineering students are involved. On the small commercial drone, we have teams working on our drone. We have a large drone that's going to deliver payloads out into the ocean as much as 50 nautical miles, fly for several hours, which is a real challenge to get drones to fly that kind of range and out over the ocean.
I started on the data processing side and I worked on that for a semester, and then I moved on to the hardware of the drone. So we were working on moving from a 6-rotor system to a 12-rotor system, and now they've moved on to an 18 one. So we've kind of been evolving this and really making the different parts of the drone work together.
This is really more in the process of how do you collect sound data. I mean, what are the steps that need to happen before I start? I'm most definitely in the more data processing side, after all of this work is done, after all the data is collected, to figure out how to use the sound data and convert it to a map.
Much greater anyway.
We have a sonar pod which is going to be dropped into the ocean down 4,000 meters doing mapping. We get data from that sonar pod that has to be processed, which graduate students in particular find very exciting to work on.
The broad goal of the project is to map the ocean floor, but that's just the first step. We've also realized with the sort of approach that we are taking, we can generate a 3D map, a 3D volume map of the ocean. The ultimate goal would be to build something that actually uncovers the secrets of the ocean, and this is one way to do it.
Duke students and professors are working together to develop innovative solutions to this global challenge, breaking new ground, understand new fields, working on a variety of different technologies to solve these problems.
It's really opened my mind a lot to the possibilities of engineering and made me so much more excited to be an engineer.